Today, we really just want to look at factors and zeros of quadratics. Our main goal when looking at these are to figure out what is that relationship between the factors of a quadratic and the actual zeros of the quadratic function's graph. For example, if you had some problem, say x squared plus 2x plus 1, and you were to do two things. First, you were to factor it and get the values x plus 1 parentheses x plus 1, and secondly, you graphed it and got this little graph. Our goal is to see what is the relationship between those factors on the left and the graph and its zeros on the right. So let's jump into it by looking at a couple of examples. So here's our example, x squared plus 8x plus 7. As we go ahead and start, we find our a, b, and c values. So our a is 1, our b is 8, and our c is 7. We can go ahead and do our x method. We get a times c on the top, which is 7, our b on the bottom, which is 8, and we just have to look for those factors that are going to multiply to 7 but add 8. Real quick, that should come out to be positive 1 and positive 7. So we take these and we'll factor and build our equation. So we get x squared plus 1x plus 7x plus 7. And we can factor by grouping, pull out an x. We get x times x plus 1, and then we get 7 times x plus 1. We pull out our GCF of x plus 1, multiplied by what left, we get x plus 1 parentheses x plus 7. So those are our factors of the actual equation. Let's graph it. In order to graph it, we're going to have to find a few pieces of information. We'll start by finding our vertex, or the center of our graph. To do that, we'll once again use our axis of symmetry equation, negative b over 2a. So negative of 8 over 2 times 1 gives us negative 8 over 2, which gives us negative 4. To find the rest of our vertex, we're going to take that negative 4 and we're going to plug that negative 4 back into our original equation, and that'll find us our y value. So negative 4 squared, remember I'm putting this in parentheses, plus 8 times negative 4 plus 7. Negative 4 squared is 16. 8 times negative 4 is negative 32. We're adding that 7. You get negative 16 plus 7, and that will give you a grand total of negative 9. So our vertex is located at the point negative 4 comma negative 9. And we can use that to fill in our t-chart, because we know that the vertex is in the very center. So negative 4, negative 9 is in the dead center, and we need to find values on both sides, both the positive and the negative side. So we'll look at negative 2, negative 3, and we'll look at negative 5 and negative 6. So let's go ahead and plug those numbers in. So let's take each of those values and plug them in. We get negative 2 squared plus 8 times negative 2 plus 7. And then we just have to work it out. We get 4 minus 16 plus 7 gives us negative 5. To test and make sure we did that right, we can jump down to the opposite of the graph and look at negative 6. So negative 6 squared plus 8 times negative 6 plus 7. We work through that, and we do, once again, get negative 5. And that's great, because that means that we've done things correctly. So we'll plug negative 3 in next. So negative 3 squared plus 8 times negative 3 plus 7 gives us 9 minus 24 plus 7. We get negative 8. Our final value, we'll throw that negative 5 in there, so we get negative 5 squared plus 8 times negative 5 plus 7. And we work that out. And once again, we are going to go ahead and get negative 5. So that means, once again, we've done it correctly. We're seeing the correct symmetrical pattern in our values. So now that we have our values, let's come back to our graph and let's mark out those points. So our vertex is at negative 4, negative 9, which is right down here. So let's mark that. There we go. Now we just need to fill out our next points. Negative 3, negative 8. Negative 5, negative 8, we have negative 6, negative 5, and we have negative 2, negative 5. Now, as always, my graphs aren't perfect. I'm not that great at drawing. I'm not an artist, but they're close enough for our purposes. So we'll sketch our little graph through here. Put our arrows on top. Now, this is another one of those problems where we haven't yet found the perfect zeros. We don't know exactly where it crosses the x-axis. So we're going to have to go ahead and figure that out. We know they're somewhere around these 2 points, but we need to confirm what they are. So let's plug some values into our equation. If I look over here at the leftmost x-intercept, it's somewhere around the value of x equals -7. So that negative value here is somewhere around -7. So let's go ahead and let's just plug in -7 and see what happens. If I plug in -7, we get -7 squared plus 8 times -7 plus 7. When we work that out, we get a 0, which is great. It means that we're correct. Our x-intercept is exactly at -7, 0, where we thought it was on the graph. Looking at the other side, it's somewhere in between 0 and -1. Since I know that if I plug in 0, I'm going to get my +7 back from my y-intercept, let's go ahead and let's try -1. So -1 squared plus 8 times -1 plus 7, well, we work that out, turns out to be 0. And that's perfect. That's, again, exactly what we want. So our other 0 is at -1, 0. So let's take all this information and look at it side by side. On the left, we have our factoring. On the right, we have our graph. So our two factors, x plus 1 and x plus 7. And then we have our graph with our two intercepts here at -1, 0, and on the left side at -7, 0. So our goal is to find a relationship between our factors and our zeros, where they touch and where they connect. So if we write down our zeros, let's see if we can see any relationships. -1, 0, -7, 0. So take just a second, look at those numbers, and see what you notice about those values. Hopefully what jumped out at you are the numerical values themselves. Specifically, that you have a -7 here and a +7 here. Over here you have a -1 and a +1. Well, what happens when you combine -7 and +7? Well, -7 plus 7 equals 0. And look, that 0 shows up back in our equation, or excuse me, in our zeros. This relationship occurs over and over. If you take your other factor and do -1, add that to 1, you get 0, which again is our y value of our zeros. The relationship between factors and zeros is that the factors of a quadratic function will tell you what the zeros are, or where the graph crosses the x-axis. And this will happen every time. But the last step is really to figure out, if you have the factors, how do I officially mathematically turn them into zeros, or find where that x-intercepts are? So think about that word zeros. It's asking you, when does this graph equal 0? So if you take your individual factors, say x plus 1 and x plus 7, and set them equal to 0, that's telling you what happens. So let's solve those real quick. So x plus 1 equals 0. We subtract 1 from both sides. We get x equals -1. Let's subtract 7 from both sides. You get x equals -7. And those are our factors, or our zeros. X equals -1 and x equals -7. Those are the points where the graph is equal to 0 and where it crosses the x-axis. Let's test this out one more time. So new example, x squared plus 4x minus 12. And we'll go ahead and we'll factor it first. So we fill out our a, b, and c. We have 1, +4, and -12. A times c gives you -12. B is 4. And we need two factors that multiply to -12, but add to make +4. So we get +6 and -2, going backwards. So pull it all together. We get x squared plus 6x minus 2x minus 12. Factor by grouping, we get x times x plus 6 minus 2 times x plus 6. Pull out our x plus 6, we get x plus 6 parentheses x minus 2. Those are our factors. So let's take those and solve them to find our zeros. So we take each individual factor, set it equal to 0. So x plus 6 equals 0, and x minus 2 equals 0. Let's subtract 6 from both sides on the top equation. We get x equals negative 6. We're going to add 2 to both sides, and we're going to get x equals positive 2. So those are our zeros. So our zeros are located at x equals negative 6 and x equals positive 2. Now to test this, we can go ahead and graph it. So let's do that. Let's fly through this and find our points. Negative b over 2a gives us negative 4 over 2 times 1, which gives us negative 4 over 2, which gives us negative 2. Plug that back in, we get negative 2 squared plus 4 times negative 2 minus 12. That's going to give us 4 minus 8 minus 12, which will give us negative 16 in the end. So our vertex is at the point negative 2, negative 16. Now that's really hard to graph. Obviously our grid here only goes up to 10, so we need to find some more points. So we've got our XYT chart. We know that our vertex is right in the middle, negative 2, negative 16. And we need some values on each side, so we'll go with negative 3, negative 4, and negative 1, 0. We plug all those into our equation, and we get a series of values like this. Again, these values are really hard to graph, so we need a few more. Most specifically, what we're really interested in are where are the zeros. So why don't we just plug in our numbers and see what happens. So let's plug in positive 2 and negative 6, our two zeros from a previous step. So positive 2 squared plus 4 times 2 minus 12 gives me 4 plus 8 minus 12, which is 12 minus 12, which is 0. So that's great. We've done it right, and we've found an actual 0. Negative 6 squared plus 4 times negative 6 minus 12 gives us 36 minus 24 minus 12, which again is 0, which is again perfect. That's exactly what we're looking for. So let's go back and let's look at graphing it. So we know the point 2, 0 exists and the point negative 6, 0 exists. But all the rest of these points, they're off of our graph. They're somewhere down at the bottom. So we're just going to have to make a really, really rough sketch. So we know our value at, as we come down to negative 4, is negative 12 way down here. And eventually it's going to come back up, but it's going to cross through 0.20. We've got our arrows on the top. It does show that our zeros here are correct. That was by finding them from the equation. We were just testing it, making sure we were right with the graph. So that's what we're going to do, is take any quadratic function and find the zeros from the equation. We're going to find those solutions or x-intercepts or roots just by looking at the equation.